Is my screen visible?
Yes, ma'am.
Okay. Now let us start with paging. Hello? I was muted for a minute. Now let us start with paging. Does anyone have any idea about the concept of paging? What are the paging is definitely again a memory management technique. Does anyone have any idea regarding paging? What is the definition of paging? How it is able to manage the memory? Does anyone have any idea regarding paging? So in a computer operating system, paging is a memory management scheme by which a computer stores and retrieves data from secondary storage. In this scheme, the operating system retrieves data in the same size block, which are called pages. So the pages are of same size. And paging is important part of virtual memory implementation in modern operating system using secondary storage to perform exceeds the size of available physical memory. Now, this is the basic definition of paging. Memory management technique that permits the physical address space of a process to be non-contiguous. Physical memory is divided into fixed size block called frames. Logical memory is divided into blocks of same size called pages. A frame has the same size as a page. A frame is a place where a page can be physically placed. This is the address mapping. Address mapping is shown from logical memory to physical memory. This is the address mapping. Address mapping means the conversion is being made. How in the mapping is done from logical to physical memory, that conversion is being shown. So this is the diagrammatic representation of paging. I want to share my whiteboard and draw. Let us share my whiteboard. Is my whiteboard visible to you all? I couldn't listen. Anyone?
Yes, ma'am.
Yes, ma'am.
Shankolita, have you able to give fees? Or yet you are not able to give? Shankolita, are you able to listen?
Yes, ma'am. This week we will give the fees, ma'am.
Okay, okay.
Both same.
Okay. Now let us write program A and in another text these are the two different programs. Suppose earlier one was program A and this one is program B. Now this one is the diagram of main memory. Main memory. Now I am drawing the diagram of secondary memory. Secondary memory. Now I am drawing the diagram of swap in and swap out. The memory pages are swapped into secondary memory, those which are not required, and whenever they are executed, it is swapped in. This is swap out and this is swap in. So whenever the program needs to be executed, the part of the program or the program is swapped out from the main memory and kept in secondary memory. And whenever the execution is over, it is again swapped out and kept in secondary memory. Okay. So this is the So now let us go back to my main screen. I think up to this there is no confusion. Now let us go back. Now this is the diagram of page translation. Is the What are frames? I have explained while explaining segmentation. I have explained this. What are frames and what are pages? Can anyone remember page translation? Page translation means I want the definition of page as well as definition of frame. Come on, I want all of you to interact. Don't stay mute. Unmute yourself and speak. If you want to explain, if you want to say something, you unmute yourself and speak. What are pages and what is frame? Look, there is a translation that is occurring from pages to frame. Frames are of smaller size as compared to pages, and they are easily accessible. Again, I am drawing a diagram. CPU, this is the diagrammatic representation. Page number, and again there is offset. Also, we need to draw a diagram. I think everyone is able to see the diagram. These are page, wait. Page number, and these are frame number. Wait. PN stands for page number and FN stands for frame number. Similarly, there are different page numbers and frame numbers. Now, from page number, okay. So, wait. From page number, that information is coming, page number and offset. And again, there is one more. Frame number and page number, and then I am again drawing offset. Here page number and offset in there, and here frame number and offset is there. So again the mapping is being done. So here main memory, and here again I'm drawing a diagram of operating system which consists of several blocks. In this block we can write OS, then these are the different entries in the main memory. Now page number to frame number. There is a mapping between page number and frame number which is done with the help of the offset. Actually, memory management is the functionality of operating system which handles or manages primary memory and moves process back and forth between main memory and disk during execution. Memory management keeps track of each and every memory location regardless of either it is reallocated to some process or it is free. Now there are symbolic addresses used in a source code. The variable names, constant and instruction levels are the basic element. Relative address: at the time of compilation, a compiler converts symbolic address into relative address. So there is a conversion from symbolic address to relative address. Okay. This is the diagram of actually what we can refer to. If we want to label a diagram, we will refer it as paging. We'll refer it as paging, and we will refer it as page map table. This is the diagram of page map table. Frame address is actually is called physical address. If we have to learn the process of address translation, then we must learn that page address is called logical address, and it is represented by page number and the offset. Again, I am drawing it. So what we can say that logical address is equal to page number plus page. So this is logical address, and frame address is called physical address and is represented by a frame number and offset. Now if we refer to as physical address is equal to frame number plus page. This is the representation of physical address. A data structure is called page map table. It is used to keep track of the relation between a page of a process to a frame in physical memory. When the system allocates a frame to any page, it translates the logical address into a physical address and creates entry into the page table to be used throughout execution of program. When a process is to be executed, its corresponding pages are loaded into memory. So, how the corresponding pages are loaded into memory means the pages which are supported that are loaded into memory. Now, suppose there is a program of 8 KB in the memory, and when a computer runs out of RAM, the operating system will move idle or unwanted pages of memory so that they can it can accommodate or it can free up the space at a given point. Then the paging concept will come into picture. All of you, are you able to understand what I am trying to say? I want an answer from all of you.
Yes, ma'am.
Okay, only one answer. Rest are silent.
Yes, ma'am. Yes, ma'am.
Ma'am.
So the process continues working during the whole execution. During the whole execution of the process, where the operating system keeps moving or it keeps removing idle pages from the main program and write them onto the secondary memory and bring them back when required by the program. Advantages and disadvantages of paging. Paging reduces external fragmentation. Sorry. External fragmentation. Fragmentation I have earlier taught. So fragmentation is reduced in through paging reduces external fragmentation, but still it suffers from internal fragmentation. Paging is simple to implement and assumed as an efficient memory management technique. Due to equal size of the pages and frames, swapping becomes very easy. Page table requires extra memory space, so may not be good for a system having small RAM. Segmentation. Segmentation is a memory management technique. We have learned segmentation. So again, it is related with paging. In next class, we will learn about the differences between paging and segmentation, although they both seem to be similar. So this is the diagram of page translation. Now, paging hardware. Every address generated by CPU is divided into two parts, page number and page offset. Page number P is used as an index into a page table which contains base address of each page in physical memory. Page offset combined with base address to define the physical memory address that is sent to the memory unit. For given logical address space of 2 to the power m and page size of 2 to the power n. I'm stopping for a minute. If there is any confusion, then you can ask. And if there is no confusion, then I can proceed with the next slide. Again, this is about paging hardware. Page number is used as an index into a page table. The page size is defined by the hardware. It means the page size is not fixed. It varies and it depends on the hardware. The size of page is typically a power of 2, varying between 512 bytes and 16 MB per page. If the size of logical address is 2 to the power m and page size is 2 to the power n, then the high order m minus n bits of a logical address designate the page number. This is the diagram which I have already drawn and explained about the CPU, page table, logical address and physical address. When we are using a paging scheme, we have no external fragmentation. Any free frame can be allocated to a process that needs it. However, we may have internal fragmentation. If the process requires n pages, at least n frames are required. The first page of process is loaded into first frame on free frame list. What does it mean? It means it follows first fit because the first frame listed is kept in the first free frame list. That means first fit fragmentation scheme is used and the frame number is put into page table. So look carefully, page 0, page 1, page 2, page 3, these are logical memory. In page table, we can see that, look carefully in the page table, that page 0 is mapped in physical memory space, which is numbered as 1. In 1, you will find page 0. Again, page 1 is mapped in the frame which is marked as 4. In 4, in physical memory, see 4, page 1 is found. Similarly, in page 3, there is frame number or page number 7. Sorry, similarly in 7th one, there is page 3. In the page table, it is seen that page 3 is mapped in frame number 7 and page 2 is mapped in page number 3. So this is the diagrammatic representation. I think the diagrammatic representation is clear. This is paging example. Free frame list is there. To implement paging, the simplest method is to implement the page table as a set of registers. However, the size of register is limited and the size of page table is usually large. Therefore, the page table is kept in main memory. I'm not getting any questions from anyone. I think everyone, please ask a question or else I will understand that all the things are clear to you all. No questions? Okay. I will ask every one of you, since every week there is a test. So this week, again, only few of you have shared screen last time. So I will again ask every one of you to share your screen, and please, this time all of you will explain paging and segmentation and the difference between paging and segmentation. Okay. If we tomorrow we will again continue with paging. I think paging and segmentation and the difference between paging and segmentation should remain clear before proceeding to the other topics of operating system. Here you can see there is an important concept of translation look aside buffer, TLB, or associative memory. What is TLB or associative memory? That we will learn in the next class. Okay. So if we want to
Okay, ma'am.
access any location, we must first index into the page table. That means is the page table, the index is needed, just like it is explained in this diagram. See, here also representation that page 0 is found in 14th frame list. See, in 14 there is page 0. So this is the representation. Okay. So in tomorrow's class, I will explain translation look aside buffer. Until then, all of you study, and if there is confusion, please ask. The meeting will end now.